Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome to WebRTC Live. I'm your host, Aaron Syme, founder and CEO at WebRTC Ventures. We are a custom design and development agency focused on building live video applications. We're here to help you take your application live. Thank you for joining us live today on YouTube, LinkedIn, and Twitch. And welcome also to any of you watching a replay of today's event. For those of you with us live, you can ask questions throughout the stream by leaving a comment in whichever platform you're viewing this. For today's episode, we're exploring what it takes to integrate voice AI into live video and WebRTC apps from both a technical and a user experience perspective. And we're joined by two team members from our team here at WebRTC Ventures who have been integral in our team's delivery of real-world voice AI solutions. First up, Daniel Phillips, lead UI designer, will share what he's learned designing multimodal adaptive interfaces that blend humans and AI. Thanks for joining me today, Danny.
Hi guys. Nice to be here. Thank you everyone that's watching.
Thank you for being here. And after we talk with Danny and have a demo of an application that will demonstrate these concepts, we'll chat with Hector Zelaya, WebRTC Developer Advocate in our team, who will walk us through the architectural choices and challenges of building real-time voice AI systems. Thanks for being here today, Hector.
Hey there, excited to be here, and thank you for having me.
Of course, of course. So for those of you watching, whether you're designing AI applications that users need to trust, or trying to reduce latency in voice AI applications, or figuring out how to route audio to an AI agent, this episode of WebRTC Live today is for you. So thanks again, Hector and Danny, and to all of you for joining us today. Let's start with Danny. So you wrote a blog post on this that's up at WebRTC Ventures about how traditional UI design just doesn't cut it when humans and AI share the same interface. So I want to start with kind of asking you the question, what's the biggest shift you had to make for designing applications for voice AI?
Right. Well, there is a lot that needs to be looked at when we integrate AI into our applications. In this particular example that we're talking about, we created for an internal product, LiveCart, which is what we're going to demo. And LiveCart was sort of created as a WebRTC-based platforms that would enable real-time video commerce with AI assistant. So think about it, when we see the demo, me talking to a live audience, a large crowd, trying to sell a product, or multiple products with the assistance of AI. And that introduces a lot of complexity, not only technical, but also UX, right? So we have latency issues, we have human in the loop issues, we have issues with a large crowd. So yeah, those are some of the things that we're going to talk about today. But yeah, it's a cool app. I think technically we did a great job. Hector will talk a little bit more about it, but we definitely try to be careful or try to expand the necessities of UX using WebRTC and AI, in this case, an AI avatar.
Yeah, so take a moment and we'll go to the demo in just a minute, so people can kind of see you demonstrating the application live and get a better sense for it. But take a moment quick, first just tell us a little bit more about it. So this is a demo application we built to demonstrate the integration of AI and WebRTC, and you'll see an avatar in there, and you said for a live shopping experience. So, you know, what is a live shopping experience, and what makes that unique?
Right. So the goal of this sort of project was to integrate this live avatar or a talking, AI with a person using WebRTC as the connection, and have them both understand that they're selling a product. There's going to be a live audience that wants to purchase the product. So I don't know. I think about it like those. I think that we still have them on TV, like late night TV, where they're like pitching a bunch of like cheap products, like
Right.
coins and like watches and those types of things. So in this case, it's very similar, but over WebRTC and using the power of AI to help you promote product, answer questions, describe the product, etc. So it's really
Yeah.
cool. It's a really cool way to see how AI is able to understand what we're selling almost immediately, and to be able to turn that information into an avatar that talks and answers questions and can interact with the seller. It's really cool.
Yeah. Yeah. It's for those, who either watch traditional TV enough or just of a certain age like myself that remember seeing those channels on TV a lot. I actually had a chance once to go on set. I was not on camera, but I was on set of one of those prominent television channels in the US and saw the operation of how they do that kind of live selling on TV. And in that sort of traditional broadcast setting, obviously you had multiple cameras and you had one or more hosts up on stage, you had producers, you had a lot of people involved in selling that product. So it's a big operation in that sort of context. But in this case, by combining AI with WebRTC and a host, in a scenario like this, you're seeing an interesting combination of the power of those things together, because that you could be kind of a sole salesperson, in that sort of scenario, using AI to help you make the sales at scale and respond to people faster, things like that. And of course, doing it kind of all remote from your home studio because of WebRTC without that other traditional broadcast equipment. So it's kind of an interesting, I think that's part of why we made this particular use case as an example. It's an interesting combination of those things and shows how differently you can do these sorts of use cases with modern LLM and video technology.
Sounds good. I think we should go to the demo, because we've been talking about this sort of thing that nobody understands until they see it. So
exactly.
Do that first.
Let's do that. Let's go to the demo, and then we'll come back and talk more about the unique aspects of designing this. So here we go. All right, recorded Danny doing the demo.
Hi everyone, welcome to this live cart demonstration. The first thing we're going to do today to get the session started is adding some products. So I have here a couple of links from a really cool website, and I'm going to be pasting those URLs into our application, and it's going to extract all the information, pictures, prices, etc., and feed that into our application context, so our AI knows what we're going to be selling. So here are a couple of products I'm going to be adding today. Okay, cool. So today we're going to be selling a watch, a pocket knife, and a foosball table. Very expensive foosball table. Cool. All right, so next step is to choose our avatar. We have a couple avatars you can choose from. I'm going to be working with Sophie today. Hi Sophie, how are you?
Hi Daniel, how are you?
Ready to go live?
I'm ready. Let's start selling.
Can you tell us a bit about our first product?
Sure, Daniel. Here are main features of the Gevrol Wallabout Swiss Automatic. Gevrol watches are for those trailblazers out there who are inclined to eschew the ordinary, opting instead to sink their teeth into the more inventive flavors that life has to offer. Like the people who wear them, Gevrol watches are distinctive, imaginative, and original.
Nice. Is the movement automatic?
That's right, the movement is automatic. It also has a case diameter of 44 millimeters. The case material is stainless steel, and the crystal is made out of sapphire.
That's nice. What's the price?
The price today, if you purchase it during our live cart session, is only $3,095.
Thank you.
You are welcome.
Right, I'm gonna mute Sophie now. And I can see some messages here in the chat. I really like the product. All right, I'm gonna reply. Yep, we can include shipping, of course. Is the watch waterproof? All right, so the bot is going to answer this one. And yep, it is waterproof up to 1 meter. Okay, I'm gonna click here on this icon to see what the information about this 1 meter is. So I can see here that the manufacturer specification says that the watch is waterproof up to 1 meter. So I can actually check the answers that or chat is given, or AI chat, based on the initial context that we gave it. Awesome. I think we can end the session for now, and that's about it for our live cart demo today. I hope you guys like this quick demo, and
All right, Danny. Thank you for doing that demo for us. Yeah, a lot of interesting stuff. And I want to be clear, kind of, for our conversation today on WebRTC Live. The point of this conversation is not, necessarily to sell our viewers on LiveCart as a product, though certainly if somebody watching this says, hey, I want to, license that code or work with you all on that, we'd be happy to. It's about demonstrating the integration of these technologies. So talk to us, Danny, a little bit about some of the key factors that designers should keep in mind as they're building applications that combine humans and LLMs like this.
Yep, sure. Let's take a look at one of the slides that we have for the latency part. Next one. Yeah, so this one. So this is something that is very important. In the demo, you don't really feel a latency when I'm talking to the avatar, running locally or whatever. But in real life, this never happens, right? You start talking and it takes several seconds, 10, 20 seconds, maybe. So what we added, and you can see it clearly in the demo, is we added this label at the top of the avatar's video wrapper that says sort of the state of the AI avatar. So as a user, if it's a complex question or a question that it's not in the context, you can see it's thinking, it's not doing anything, but it's listening. So ready to sell in this case would be listening. And then when it's talking, you can hear it obviously, but we also add that label. So this was a great way for us to tackle that latency that is going to be inherent in this type of applications because of connectivity, etc. And it's immediate, right? It happens before it's like a separate message, I guess, or webhook or whatever you want to use for technical, but it's separate from what the chat is doing, and we're able to tell or show the users immediately what's happening, and it's great visual cue for the user to understand that something's happening. The app's not stuck, the app's not broken, it's just doing what we show on the label. So this was one of the most important sort of little things that we added. The next thing that we can go, maybe show the next slide. Yeah, so at the end of the demo, there's a question if the watch is waterproof. And this chat is also connected to an LLM that uses the context. And we want to make sure that those answers are, correct. The LLM's not giving false information. We can, end up selling a watch and make promote a sale based on false information would not be good. So we added this brain icon. In the demo, it's a little bit blurry, but it's a brain icon, and you can click on it and see where the information comes from. So this is sort of a user in the loop kind of thing. Actually, if we go to the first, here, this is the information that we were looking at the watch. I'm sorry, in the demo, is we're able to see where the answer comes from, right? So in this case, me as an admin, I can see what the chatbot did and what the answer was and where the answer came from. So I can actually click on the link here in the same answer that was given in the chat and verify that the answer was correct, coming from, in this case, the producer of the watch website or the website that we used as the context. So this is something super important. And yeah, so those are two things. That the other one would be sort of the concept of user in the loop kind of thing, which is sort of a mix of what we're talking about. But if we go back to that third slide, is also giving the user sort of the options to give us feedback, right?
Mm-hmm.
So here you can like or dislike a question or an answer, sorry, and also look at the transparency icon and actually verify that the answers are accurate. So yeah, those are the sort of the three most important features that I think we implemented into the live card demo. Yeah.
Yeah, and I like how in what we're seeing on this screen, there's a pretty clear delineation between what is a comment from the human host, of the selling session, you in this case, where you say, yes, we can include shipping on the price, versus something that the LLM, that the avatar is providing to us. For users, that will be pretty clear who's communicating, which one there, and then providing the feedback and being able to see sources about that goes a long way towards building trust, as you said.
Yeah, exactly.
One of the other things that I think you implemented that was interesting was for like human in the loop, help letting the human host kind of jump in instantly through keyboard shortcuts. Can you talk a little bit more about that and how you decided, to implement that?
Right. So the keyboard shortcuts came from a struggle to interact with the chat, because it's different. I don't know. It's when you're talking to someone, you want them to mute or shut up or stop talking. I don't know. Maybe it's something that we as humans are able to take cues easier, but when you're just talking, and also latency is a big factor. When we're testing these voice applications, it's hard. Like they start talking and you want them to stop, and then it's kind of a cut on what the AI is trying to say, and then you say, "Oh, shut up," or "It's okay, don't talk to me anymore." And then they're like, "Okay, I won't talk to you anymore." And then they're talking over you without them really knowing, right? So those sort of interactions can be kind of weird. So we thought about adding these shortcuts with the keyboard where you can mute, you can, sort of create this pre-created prompts like, okay, if I press, Command P, I'm going to ask a question. So then the chat or the avatar can, or the AI behind the avatar can stop, can listen, can understand that what's coming is a question, or it can just mute and stop talking completely. So those sorts of interactions, of course, they're limitless, right? You can add whatever shortcuts you want, and
Right.
and create them towards the needs of your application. So I think those were really helpful, especially when muting, right? You don't want to say, "Oh, hold on, oh, stop, I'm talking," or "I'm not ready for your answer yet." Just mute it, finish what you're saying, and unmute, and then the AI will understand that it's time to sort of participate in the conversation again. So
Yeah,
those work really
absolutely.
good.
I mean, it's a great example of how important the design, the technical architecture system, and Hector will probably talk about this more in a moment, is the way you do that is really important to reducing latency, so that, like if the LLM hears you start to talk, it knows to pause and let you speak, right? And so the lower that latency is, the less chance there is that you and the LLM are trying to talk over each other, which would obviously be disruptive to viewers. But then going beyond that, the capabilities you just talked about with keyboard shortcuts, of making sure that you can control that too, to make sure that the interaction is as seamless and as possible, because as two humans talking to each other, right, we can start to see when one person wants to interject in the conversation, that sort of thing, right? But an LLM by itself is not always going to pick up on that, certainly with current technology anyway. So building that into the design, another great example of how you have to design things uniquely.
Right. We would almost need, which would be another feature to add to this application, is sort of a computer vision aspect of it, where if you pick up your hand, then that creates a message. or if you go like this, that creates message, stuff like that. So, or if you go like this, oh, okay, I'm thinking, or it could be cool, but that just adds another layer of complexity that
Yeah.
can be easily solved with either. I mean, it could be a button, but in this case, we decided to use the keyboard shortcuts, which are really useful. So
Yeah. Well, and I think that's sort of like video-based understanding for an LLM of you raising your finger like you want to talk type of thing. No doubt it's on the way. I'm sure we'll see that at some point and be building that into applications that we work on. But also, depending on the use case, doing real-time processing of video is inherently going to add some latency and certainly some technical complexity and cost. So when you have a scenario like this where you can address that with a simpler implementation through the design, through interaction, that's really good to consider too, rather than having to go to the real-time video analysis. Though, like I said, it's on its way, no doubt.
Yeah, for sure. There'll be a next
awesome. Yeah, exactly. All right. So speaking of kind of technical next steps, let's switch over to Hector and talk a little bit about how these applications are built. So Hector, thanks for joining us today. Also, now you just gave a presentation on this topic, kind of a similar, around the same sort of technologies and application at an AWS Community Day in Mexico City. So thanks for sharing your expertise there, as well as with us on WebRTC Live. Let's talk about the back end. Tell us a little bit about how this application was built, what makes it so difficult to do these.
Yeah, so there's a thing with the voice AI application. It is the fact that it brings both the complexities of WebRTC application and the complexities of AI application plus their own complexities. So when you're building voice AI applications, you have to deal with things like transporting media in multiple network conditions. Sometimes these will be adverse conditions. Those come from the WebRTC side. There's also the efficient management of the context window in the AI. And you have to do all this in a way that produce the less latency that you can get. And specifically with voice AI, there's the thing about turn detection, something that, if you allow me to say, that's also difficult for humans
Right.
to know when you should start talking and that. And there's the issue about interruption that you have just said. So these are kind of things that without the right expertise, it can be very difficult to manage. And what is that expertise that you need? Well, you need the expertise on real-time communication, specifically with WebRTC, and any kind of way that or protocol that allows you to transport media. And you also need to have the right expertise to architect your AI application and stack in the right way. So the first thing you need is the appropriate WebRTC platform, whether this is self-hosted or it's on-premise or is using CPaaS provider. So that's the first thing that you need to define, and we can help you with that. And there's once you have that platform integrated, and if you allow me to share a couple of diagrams about this. So you decide your interfaces that you want to support, whether you want your users to interact via telephone. Then you will also need a node that takes the audio from traditional telephony to your WebRTC platform. Or if you want to also support web, as in the demo that we have just seen, or maybe a native application. And once you have that, that's the place where both your users and also your bots, your agents are gonna meet and are gonna interact. So that's the first thing you need: build the appropriate pipeline. And while you're there, you also need the right approach that will depend on the use case for turn detection. There are some other models, AI models like Celero, which is a great voice activity detection model. But depending on the use case, you can also apply multiple approaches, such as push to talk, for instance, which can make sense like in a web scenario where there's a specific button or a specific shortcut that you can take in order to start interacting with the bot, or when you want the bot to stop interacting with you. So that's the other thing. And then when you are designing or writing your agent, you basically have two approaches. This is the typical, where you have your application that it's in charge of processing the input and transporting across multiple other models. Initially, you start with a speech-to-text model that takes the user's input and converts it into text, a text that you later put into a large language model in order to produce a response for the user. And that response is also in text format that you pass to a text-to-speech model that it's going to convert that audio into text, into the audio that your user is going to hear. That's the typical architecture known as cascade. And well, you have to architect your application in a way that each interaction with each of the model is done in the least amount of time possible. Ideally, you will want to use these models either co-located in the same node or in the same network, or in locations that are close to each other, and or using models that are real-time optimized, so that all this processing happens in a reasonable amount of time. There's also the approach where you can remove the speech to text and also the text to speech, and instead of a large language model, you use a large multimodal model. So in this case, you can directly inject the user's input into the model, and the model has the ability to process it on its own and create also an audio response. Now, this also comes with its own set of challenges on one hand, and it also comes at a higher price. So it's a trade-off that you need to make in that scenario. There's also the thing with large multimodal models is that, at least at this moment, and last time I checked, because this could change from yesterday to today, but last time I checked, the large multimodal models were not as intelligent or as powerful enough as state-of-the-art large language model. So for some use case, of course, you can go ahead and use a large multimodal model if you have the budget. But for the majority of the cases, you will see, or you will have an agent that follows this cascade with this initial set of model, because of course, depending on the use case, you can have some other, you could be running some other smaller large language models or large multimodal models in parallel to help with turn detection. Or if you're working with avatars, there's also the idea of perception models that allows to react to what they see on the image. So yeah, that's the thing with voice AI, but with the right expertise, is indeed something that that you can manage.
Yeah, definitely. Well, I appreciate you sharing your expertise with us around that. Can you talk a little bit about the avatar part of the LiveKit demo application and how that was implemented and any unique challenges that that presents?
So with avatars in general, one particular challenge is the ability to lip sync, because some of the service, what they produce is a video stream that you have to put and stitch together with the audio that your text to speech model has or produces. Now, for this particular implementation, we use a service called Simlim, which I'm not trying to sell by any means, but is this service that we ended up using. And they had the feature that they not only produce a video stream, but they also they kind of resend the audio stream, and they already take care of the lip sync process, which if using some other service is, well, something that you will need to do in your application, and that usually involves messing up with or dealing with the timestamps and trying to make that match. So that's additional processing that you need to consider in your latency budget. That's one thing. Now, with avatars in general, there's the emotion or gesture perception, so that the avatar can react on if it sees you mad, angry, or if it sees you sad or laughing. So it can react to that. And there's also the emotion rendering, so that the model can also adapt. And if you say something sad, the avatar is not going to laugh. So these are usually additional models. There are some avatar services like Tabus is one of them, that they produce their own emotion perception and rendering models. So yeah, it's another challenge that, depending on the use case, if you have an avatar that is acting as for therapy, you will definitely gonna need something like that. Or if you only need like a hologram or something that will be like this, then you might not need that. But yeah, it's another thing to consider. There's another challenges are having to deal with the audio that your text-to-speech model produces and match it with the input of the avatar, because sometimes the avatar services has some specific requirements about sampling and about things that the audio has to match. So you also have to consider that in your processing. And finally, is how to ingest the audio and video frames that you get from your avatar service, and how do you ingest that into your WebRTC session, which is gonna be highly dependent on whether you are using a CPaaS, whether you are hosting your own infrastructure, and it's something that you have to either handle or have that communication with your provider or with your platform's engineers.
Yeah, fascinating. There's a lot to consider in architecting this, right? I mean, if we think about like the WebRTC meeting tools that we were building 10 years ago in our team, you were kind of thinking, your architectural choice was mainly, do I want to use a commercial, a CPaaS off the shelf, or do I want to build a media server using open source? But now, as we're combining these, and we're doing this increasingly in our work, right? You still have that sort of decision to make, which is an important decision to make. What do we want to use as the media server for the real-time video and audio? But now also, what do we want to use for an avatar service? What do we want to use for the LLM? What type of LLM do we want to use? Is it text to speech to text, and going through that cascading design that you described, or is it a multimodal LLM? And then what are the APIs between all of those things? So you have a pretty fast growing number of different combinations you could consider, right? And so that's where we see that these things are not as drag and drop as they're advertised when you combine them together, and then you're trying to do all of that at scale. So obviously having somebody like you on that team to bring in that expertise of how to best connect these together, as well as somebody like Danny in terms of how do we make the interface of all of those things seamless and easy to use and easy to understand for users. We can see where these things still get complex, for sure.
Yeah, definitely.
So, given kind of all of that complexity, what would you say, what tends to break first in a voice AI system like this? Like, what would you want to watch closely or monitor if you're going from the prototype to now we're deploying this and doing it at scale? What would you be most concerned about?
Yeah, I think the first thing to consider is how much processing do we want to add between the time we get the user's input and the time we produces an output, because each processing is going to add up in the latency budget. So
Right.
The less we do in that regard, that's going to help us on having a natural conversation flow. That's one of the first things to manage. And also we want to have monitoring and observability on how that behaves over time, and try to catch any performance issue that could raise up. So that's the first thing. The other that is somehow related is that if we are interacting or integrating with external APIs where there's going to be network requests and networks waits for that, is always rely whenever possible on cloud providers connection speed. So if we want to connect with a service that it's not that close, we better do that using a high-speed connection, which is something that it's only going to be available on a cloud environment, and we could use any kind of edge location or edge servers that they can have available, so that users always connect to a server that is close to them, even if the external provider is not that close. So that's another thing. It's important that we always use real-time optimized models and or services, because some initial models might provide with a good with accurate responses, but they will probably take longer time to produce their output. So we should prefer things that are real-time optimized, and whenever it's possible, we want to collocate models. If we can reduce those network requests, that's even better.
Yeah, absolutely. Yeah, so you mentioned like looking for models that are real-time optimized, or maybe multimodal, things like that. Are there any? My last question for you before we bring Danny back too for a final question or two with all of us. Are there any tools that developers can use to make building voice AI applications easier, so they don't have to reinvent the wheel every time? Any
definitely.
favorite frameworks so far?
Definitely. Actually, related to what you were discussing about how in the initial state of development WebRTC application, we had to decide whether we want to go commercial, whether we want to go open source. Things have changed, and now even commercial offering now kind of wants to fit in the open source, and there are some providers such as LiveKit that allows to use their or allowed to host their servers in your own cloud, or for instance Daily that allows to get their or mimic their infrastructure on AWS through the marketplace. And at the same time, they are also producing frameworks that are open source and that you can use, and somehow they already abstract some of the complexities that comes with voice AI. So there are tools like PipeCat by Daily or LikeIt Agents, and I think Twilio also recently released their conversational relay. So these kind of things already takes care of most of the best practices and abstracts most of the complexity and provides some nice ways so that you can integrate with turn detection models and integrate with most of the available speech to text, large language model, large multimodal models. So when it's available, it's always a good idea to use one of these frameworks because they will make life easier considerably.
For sure. Excellent. Yeah, anything we can do to manage the complexities, good for us and our team at WebRTC Ventures, good for our clients, good for anybody trying to build applications like this. All right, let's bring Danny back on stage as well. And as we're in our last couple of minutes here of our conversation, I want to ask you, Danny, what do you see as like the future of interfaces in AI-driven applications? What are the thoughts you have? Where are we going next in this?
Right. Yeah, there are definitely a bunch. Can you hear me okay?
Yep.
There are definitely a bunch of new UX things that we can do to applications that will help us improve the AI implementation. Not everything applies to WebRTC, right? Some things are sort of for other needs. But one thing that is already being implemented in a lot of AI applications is the use of this process flow canvas document styles, right? Where you can sort of create these nodes with different AI sort of processes and start to sort of lead your AI to where you want to go. This is something that can definitely be used in lifeguard application would be a good way, if this user does this, do that. If this is the answer, then take them to a shopping cart or whatever. So that's sort of interface that is sort of, I don't know, like a Canva kind of thing where you start moving nodes around to connect flows. That's a really, I think, something that's going to be used a lot in SaaS applications, and people should definitely start getting used to them because I think those are going to be used a lot. And the other thing that I think is super cool is the use of this interface or artifact interface where you can collaborate with the AI. So if you're creating a document, you can type within the document that the AI is also typing, or if you're, I don't know, working on generating an image, you can already kind of do this with some of the image generators. You can sort of select the eyes and ask the AI to only change the eyes. Right? There's a cool trend a couple months ago, maybe, where people would create an ugly sketch and then they would write with words. Oh, make this hair blonde and make this desk out of wood, and then they would upload this to a model, and the model will get a basic idea of the drawing and then understand that where the words were is where it had to interact. So there's sort of ways to collaborate with a model that feel more human, I think are things that are going to start becoming more available to us in these AI SaaS tools.
Yeah. We'll be working on collaborative documents together and images and doing all of this in the midst of a live video conversation like this, and maybe while we're streaming it out to people as well. So yeah, lots of interesting combinations of all of these technologies coming up. So I really appreciate the expertise that both of you have shared with us today. Thank you, Danny, and thank you, Hector, both for sharing your expertise with us today on technical and UX approaches for integrating video, voice and video AI into WebRTC apps. So thanks a lot, guys.
Thank you.
And thanks to all of you for joining us today. We have some additional special content that Hector and Danny and others have put a lot of work into. For those of you watching today, if you go to ai.webrtc.ventures, the link on the screen right now, on that page, there's a link to a white paper from our team with 5 tips for integrating LLMs into your WebRTC video and voice applications. And I want to say these are really more than just 5 tips. There's a lot of great details in this content. So a lot of great insights in there that I think you'll get a lot of value out of that. So to access that, just visit us at ai.webrtc.ventures. Thanks again, guys. Appreciate it. All right. So in just a moment, I'll have Sahi joining me for our industry analysis segment, where we'll talk about if WebRTC has become too complicated. But first, let me remind you that this video will be available on the WebRTC Ventures YouTube channel, as well as on our blog, on our website, on our blog at WebRTC.ventures. Our next episode of WebRTC Live will be Wednesday, July 16th at 12:30 Eastern US. Our guest, Yahia Salman, is an engineering student and AI researcher from George Mason University. We'll be talking about another really, if you enjoyed today's episode, I think you're going to really enjoy this one as well. An interesting project where you combine Zoom real-time media streams with an AI assistant that understands everything said and shown in a Zoom meeting using vision language models and large language models and retrieval augmented generation. So going to be a lot of really interesting content in that next episode of WebRTC Live as well. To find out more about our upcoming episodes, follow us on social media at WebRTC Ventures on Twitch, LinkedIn, YouTube. Join our email list at WebRTC.ventures. So thanks everyone for joining us today. Let's make it live. Thanks for joining me today, Sahi. You know, sometimes I long for the good old days in the early 2010s when we thought WebRTC was going to be so easy. Just drop a little JavaScript in. You've got a video chat app. But a lot's changed since then. Maybe not entirely for the better. I don't know. What do you think? Has WebRTC become too complicated?
I think it's still the same. You still write the same piece of code and you still crop it there and everything is fine.
Yeah.
I think the problem is kind of elsewhere, and it's not necessarily a problem. When we started out, I was working a lot with H.323 and other signaling protocols, where the thing was, and I was very conversant in H.323. It's like the protocol today, and you can do things in a gazillion different ways.
Mm-hmm.
So there were different ways to start a call. You can do the setup through Rust messages, and then there was H.264 and signaling over Q931, and you can do it with it and without it, and like lots and lots of different options. And whenever we had to take the protocol stack implementation and actually test it before launching and updating a version for a customer, that would be months and months of work, just going over a lot of different configurations. And then something like WebRTC comes out. There's Opus. That's it. Yes, there is G711, but nobody is using that except some call center vendors, and I still don't know why till today.
Right.
And then they had VPA. That's it. That was it. Nothing else. There was a fight, and they had to add H.264. Fine, that's okay. But that was the end of it. It was nothing more, nothing less. And it was with SRTPs. We had security and privacy. And that was intentionally mandatory. So you couldn't say, I don't want it. And I remember in the first 2 or 3 years, all of the messages that came was, can I use unencryption? Can I use encryption? Why is it encrypted? Can't I remove that as an option? And the answer was, no, you can't.
Right.
And that was just great because, it simplified a lot. Now, fast forward to today, we know a lot more about the things that can be done. We have more codecs simply because time went by, and yes, VP8 is still nice, but VP9 is better, and H1 is even better than VP9. So we want better codecs. And we have some new techniques like RED for dynamic encoding on audio, which we didn't have before. and there's more use of things like forward correction inside the video part, and there's better packet loss concealment, and better band optimization, and echo cancellation. And there's a lot of different ways to build the whole backend, simply because we know more of what can be done. So we can use simulcast or SVC or none of these and do mixing. And it's not that these didn't exist before, some of them didn't, but I think that the use cases became so nuanced that we actually want to pick and choose the specific configuration and optimization that we're doing in each and every step of the way.
Exactly.
And to squeeze the lemon as much as we can. So it's like it was good enough. It is still good enough, but we want something better. And part of it is because the large companies, let's say Google Meet, is doing a lot better. And then a lot of the complaints is, well, Google Meet works better. Why isn't my application as good as that? So that's one of these things that you hear quite a lot. It was Zoom, oftentimes. Now I hear more about Google Meet being compared to my WebRTC application. So we came to a point where it became very complex, but it's hard to say if that's because WebRTC became more complicated over time, which it did, okay, or because we're trying to get more out of WebRTC today than we used to 10 years ago.
Yeah, exactly. And I think that's where, like, your comment about the nuances of the use cases, I think, is key to this, because it does depend on the use case, right? WebRTC was envisioned for things like Google Meet more often, and more has been added to it. And if you're building a simple meeting application, it's probably still simple to use. If you're trying to use it in a lot of other use cases, like I was asking my team, what do you find most complicated about it? And, it was still, firewalls, and still scaling for large conference calls, scaling for broadcast, right? Another thing is it's often not just WebRTC. So sometimes the complication doesn't have anything to do with WebRTC so much as the things you're trying to connect it with, right? You're trying to bring in an RTMP stream with OBS. You're trying to integrate with SIP for telephony, right?
Or an LLM.
And exactly. Now you've got voice AI, LLMs into the mix. Exactly. So, and so I think for certain use cases, still pretty simple. And in fact, simpler than it was 10 years ago, really, if we're honest. Let's not sugarcoat the past. In the past, we had more browser issues to worry about, right? We don't worry about that so much now.
And there's a lot less browser issues, but then you don't need to install a turn server either. You can just go and use one of, 6, 7, 8 different managed turn services that are out there.
That's true. Yeah. You still need it, but you have more choices for it. It makes me think this is a little bit like in last month's episode of WebRTC Live, we were talking about media over quick, right? So, that's an example where for some use cases, you could say that WebRTC has become too complicated, perhaps. And so doing things with web transport, media over quick, even though they may be, in some ways, they're like lower level and more complicated to work with, but for certain use cases might be better. So, maybe if WebRTC feels too complicated, is that kind of the alternative to look at, is just look at, some of those unbundled WebRTC solutions?
I'd say, first of all, no. Because I do things with WebRTC and I want people to come to me, but
right.
For the most of us, it's too early.
Yeah,
that's the main reason. Ask me a year or two from now, maybe the answer will change. It probably will to some extent.
Sure.
Then it would depend on the exact use case and what you want to do with it. I remember there's a guy called Jeff Atwood he was a really good blogger. And he wrote about software engineering. And he had this, I think it was Jeff Atwood's law, which was something like, whatever can be written with JavaScript will be written with JavaScript. And
right.
The point of it is that I don't care how much complicated it's inside and what I'm going to do to just make it ugly, as long as it works on the surface in a simple way. So I don't care what WebRTC does. I don't care how the infrastructure looks. If that's going to solve my problem and the ecosystem is there in place, we're going to use it. Why? Because there is nothing better today. Yes, go do things with web transport. That means going back 10 or 15 years from today and saying, well, but it only works on Chrome, and even there are bugs, and we can't really use it, and there's a problem when I use WebAssembly to do the error cancellation that I wanted because it's not working exactly as I wanted. It depends which world you want to be in.
Right.
And the people that are very enthusiastic about something like media over quick are the ones that like to build stuff from scratch. And
Sure.
that like open the engine and see what happens inside. I'm one of them. So that would be, if I had to build something from scratch today, I would go use web transport. Why? Because it's interesting and it's fascinating and it's something new and like, it's almost the exact same protocols and capabilities because, it's still using codecs and there's still going to be a jitter buffer and we're still going to need echo cancellation there and packet loss concealment for their correction, but we can do it all over again. And do it better this time because we're smarter. Okay?
Right.
So that's going to be fun to do as an engineer.
Yeah.
But if I were someone that needs to run a business, hell no. I mean, I would put that on the CTO group as a research work for something that we will need to be ready for 2 or 3 years from now. Because there's a point in having things that work.
Yeah.
On a different note, I remember talking, it was 15 years ago, I worked at Amdocs for 3 years. And then Node.js just started out. It was the best thing ever. You could do things quickly and build, APIs and gateways and stuff. And there was a very good system architect there. The guy that you would say, well, if I open a startup, I need to take him with me as, the first engineer and as a co-founder. And he was with me for the things that I was doing there as a product manager. And I came to him and said, why aren't we using Node for that specific project that we had, which was a kind of an API gateway for all of the products of the company. Then he said something like this. He said, at Amdocs we have around 10,000 engineers. The programming language that we use here is Java. Now, if we now introduce something like JavaScript for the backend, we're not going to have anyone that will be able to maintain that. Not in the product team, not in the services team, not nowhere in the company. So picking that kind of a technology would not work for us. So when you go and pick something like media over quick web transport, you also need to think about the skill set that you're going to have in that company or that you already have. Do they meet the needs of using something that new? And that's a question to ask, especially when you go and look, the companies that complain about WebRTC are doing that because they don't have the skill set to do it with WebRTC. And WebRTC has been with us for 14 years. So how would something new that doesn't exist would have the skill set of the developers that are so enthusiastic of using that because they hate WebRTC for it? So it just doesn't compute for me that thing. Now, I'm not against web transport and media over quick. I think it would be the best thing ever for specific use cases, which are in a way a lot bigger than what we're doing with WebRTC today. Let's be frank. It also it's a lot flexible. At least web transport, we can do it with higher latencies and provide better media quality at that time latency that we're looking at. So there's a lot of potential there. But then what is the timeline? When do you want to have that available? Is that today because I have a product that I want to ship, let's say end of this year, beginning of 2026? Or is that because I had a dream for something that should happen in 2028?
Right.
So that's
And then you need twice the engineers, right? Because you're going to build the WebRTC version for now. And if it is a use case that will work better with web transport and media over quick in the future, you might need a separate team starting to work on that, but not quite having that as your production version yet. I mean, it does all come back to the nuance of the use cases, I think, for sure, is incredibly important here. So what's the answer? Is WebRTC too complicated? No, but depends on your use case. But maybe it's good that it is good that we're integrating with so many things and making it complicated, that it's widespread enough now that it seems this complicated sometimes.
Yeah, so is WebRTC complicated, or the use cases that we're trying to achieve are now more complicated?
Right, exactly. And that's a good thing.
Mm-hmm. Yeah,
that's a good thing. Excellent. All right. Well, as always, Sahi, thanks for sharing your insights with us today. To learn more about Sahi's work, you can check out bloggeek.me. To learn more about future episodes of WebRTC Live, check us out at WebRTC.ventures. Thank you, Sahi.
Thank you, Aaron.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.ventures to learn more about our custom design and development services, and to learn more about upcoming episodes of WebRTC Live.